Welcome, everyone. We're about to do something most teams talk about but few actually achieve. Stop repeat failures for good. In this session, I'll walk you through a global 8D problem-solving sprint the way automotive expects it to be done. Evidence-based, fast, and permanent. By the end of 15 minutes, you'll have 3 powerful tools. A clean point checklist showing where to draw the line between good and suspect stock, a root cause test pack that turns opinions into evidence, and a Poka-Yoke-First playbook that reduces escapes by double-digit percentages. We're talking real impact. Cutting parts per million escape rates by 30% or more, slashing complaint counts, and saving thousands in cost of poor quality. If you stay with me to the end, and you will, you'll see exactly how your team can get those results and why you'll never go back to just filling out forms. In the automotive world, problem-solving isn't optional, it's mandatory. When a defect escapes, the true cost isn't just the non-conforming part. It could be premium freight to airship, replacement parts, sorting and rework that kills capacity, line-down penalties that blow up the customer's P&L, warranty claims that drag on for years, and perhaps worst of all, the long-term hit to trust. One avoidable escape can erase a quarter's worth of profit. That's why OEMs demand evidence-driven 8D analyses. It's a common language to protect the customer, fix problems permanently, and drive systemic improvement. Here's our roadmap. D0 is emergency response. Triage, protect the customer, and declare a clean point within 24 hours. D1 assembles a cross-functional team and sets a daily cadence. D2 turns noise into data with a measurable problem statement, an IS/ISNOT analysis, and a quick measurement system analysis. D3 establishes customer protection, quarantine suspect parts, verify containment, and set up a firewall. D4 digs into root cause and escape with tools like 5Y, Ishikawa, and cause tests. D5 selects permanent corrective actions, Poka-Yoke-First, covering all root causes. D6 implements and validates those actions with both quick checks and long-term capability studies. D7 prevents recurrence by updating standards, rolling changes to similar products, and building the lessons into layered process audits. Finally, D8 closes with evidence, approval, and celebration. In automotive, this sprint generally follows the 1-5-20 rule. Contain within a day, find and agree the root cause within 5 days, and prove the fix within 20 days. Picture this. You're deep in your day when the phone buzzes. Customer says, "Our line is down, your bracket won't fit." Your heart sinks. 3 months ago, you chased a similar whole-size issue. You thought it was resolved. The clock is ticking. Every minute of downtime costs thousands. If you do nothing, you could lose the customer and lots of money. In this moment, you need more than a guess. You need a structured response that protects them immediately and prevents it ever happening again. The fire you feel right now is the fuel for learning. We'll channel it into a methodical sprint. The goal of D0 is simple. Protect the customer and put out the fire. Immediately decide whether to stop shipments or launch 100% sorting or rework. Open a visible log with times, quantities, and owners. Within hours, declare your clean point, a lot number or timestamp after which every part shipped is verified good. Important thing is that, don't guess. Include evidence such as inspection records, lot IDs, and photos. Communicate your containment plan and clean point to the customer through their portal. Use data to reassure them. Share how many suspect parts were quarantined, how you verified the firewall with run charts, and what's being done upstream. A clear, data-backed clean point calms the customer and buys you time to do real analysis. D1 is about people and communication. Assemble a cross-functional team. Process, quality, maintenance, tooling, logistics, and sometimes supplier quality. The key point is that creating team with a multidiscipliner people. Make sure each member has the skills to analyze the root cause, define and implement corrective actions, and monitor their effectiveness. Appoint a team leader experienced with the 8D process, and a sponsor or champion who can remove roadblocks. Establish a daily cadence for internal stand-ups, and set a single voice to the customer portal, no mixed messages. Ground rules like meeting discipline, escalation process, and record keeping set the team up for a smooth sprint. Now let's convert frustration into data. Be careful while performing D2 section. It is important to clearly define the problem you are facing in order to resolve it correctly. Write the problem as a quantified statement: defect, object, location, timing, and extent. Include the customer report, the failure effect, the exact specification deviation, defect location, and production details. Then build an is and is not grid, where and when the defect is found, and, equally important, where it is not. This eliminates random guesswork and highlights the most likely root causes. Use the 5W1H method to gather all relevant facts. What object has the problem, when it was observed, where it occurs, who or which qualifications are involved, whether there's a trend, and how the deviation manifests. Collect data and facts: production date, shift, batch, measurement results, and reject rates. Next, verify that the data you're using is reliable. Perform a quick measurement system analysis or gauge R&R check. If your measurement variation is over 30%, the system is unacceptable. Between 10 and 30% is conditional, and below 10% is preferred. This quick step 2 prevents you from building an 8D on noisy data. Finally, set your targets clearly. Without a defined specification and acceptable performance criteria, teams will debate opinions instead of facts. Tie the problem statement back to a customer requirement or spec limit. That way, success is clearly defined when you select corrective actions. D3 builds a firewall while root cause work proceeds. Containment actions protect the customer by isolating the problem from the entire supply chain and avoiding delivery or assembly of suspect parts. Actions can include 100% inspection, sorting checks, or rework. Define responsibility and start dates for each containment action. Monitor status and assess risks, because containment itself can introduce side effects. Verify effectiveness with data. Use run charts or additional gauge checks to monitor defect rates and confirm that no further bad parts reach the customer. Clearly mark dirty and clean areas so employees don't mix suspect and verified material. Remember, the firewall stays up until you've validated the permanent corrective action in D6. D4 is the heart of the 8D. Root cause analysis must consider 3 levels: the technical root cause, why the defect occurs; the quality assurance or escape cause, why it isn't detected; and the systemic or development root cause, why the system doesn't prevent it. Neglect any of these and the problem will return. To ensure completeness, use the 3-legged 5. Why? Perform a separate 5. Why on each leg: occurrence, escape, and systemic. Start brainstorming possible causes using Ishikawa or fishbone diagrams when the cause is unknown or complex. Categorize potential causes across men, machine, material, method, measurement, and environment. Then use 5 why to drill down, remembering that 5 is just a rule of thumb. The root cause might emerge after 3 questions or 7, so do not fix yourself for 5, dig it until you find the cause. Next, apply a cause test for each possible cause you find. Does it fully explain the data, partially explain it, or not explain it at all? Eliminate causes that don't match. For ambiguous ones, do further investigation. When multiple interacting factors are suspected, use fault tree analysis. Most importantly, verify every proposed root cause. The root cause must be something you can turn on or off at will. Reproduce the defect by manipulating the suspected cause. Confirm the defect disappears when the cause is removed. Only when both occurrence and escape causes are proven with data do you proceed to D5. In D5, you choose actions that will permanently remove the causes you've verified. Start by listing potential corrective actions covering all root causes. Verify and evaluate each one. Perform a risk analysis. Weigh the advantages and disadvantages and be careful of unintended side effects. Establish acceptance criteria and use tools like PFMEA to assess risks. Prioritize Poka-Yoke, error proofing that makes the defect impossible, over additional inspection. For the occurrence leg, consider sensors, 3 interlocks, or automation to prevent misassembly. For the escape leg, improve detection by upgrading gauge sensitivity or increasing sampling. For the systemic leg, update design guidelines or maintenance plans. Choose the simplest, most cost-effective solution that covers all root causes. Don't forget the human side. Update training materials, work instructions, PFMEA, and control plans, so the new process is documented and auditable. Employees must understand the new standard. Simply posting a notice isn't enough. Refresh training for operators, quality inspectors, and maintenance teams if needed. And remember the cost of quality. Investing in prevention may have a cost up front, but it reduces warranty expenses and complaint handling later. Corrective actions must address the root cause, the escape cause, and any systemic weaknesses. With the right actions, you'll often see complaint rates drop by 30% or more. D6 answers the question, do the actions work? Begin with a documented implementation plan that assigns responsibilities and dates. After installation, run a quick check, a provocation test, to deliberately challenge the new control and show that it catches or prevents the defect. For example, intentionally introduce an undersized drill bit and confirm the interlock stops production. This immediate test verifies that the new Poka-Yoke or detection control behaves as intended. Then run a long-term check. Collect data under normal conditions and evaluate process capability. Look at your CP and CPK values, failure rates, and product audits. Only if the process is both stable and capable, you can remove containment. Simulation matters too. Perform rabbit part audits or golden part verifications by running known good and bad parts through the system to ensure it discriminates reliably. Conduct both product audits, dimensional checks, functional tests, and process audits. Confirm procedures are followed, gauges are calibrated, checklists are complete. If validation exposes gaps, return to D5 and refine your actions. Many repeat failures occur because teams skip rigorous validation. Don't let that happen. D7 ensures the fix spreads and stays. Start by updating relevant documents. Drawings, FMEA, control plans, maintenance plans, and standard work. Extend the changes to similar products and processes through Yokoten. Read across. Ask where else this issue could occur, and implement the same controls proactively. Set up or refresh layered process audits, daily line checks, weekly supervisor checks, and monthly management audits to verify that the new controls are present and effective. Add specific questions to your LPA checklist. Is coolant concentration logged? Is tool life counter below limit? Has the pin gauge been verified with a master? What gets checked gets kept. Capture lessons learned and share them widely so future products don't repeat the same failure. Document the systemic weaknesses identified, the evidence you used, the fix you implemented, and the performance improvement you achieved. Use a simple template: problem, verified cause, permanent fix, evidence of effectiveness, and where else the fix was applied. Disseminating this knowledge leverages today's defect to make tomorrow's product stronger. Continuous improvement isn't an afterthought, it's how world-class factories evolve. D8. Closure is more than sending off a report. It involves evidence, acceptance, and recognition. Finalize the 8D report, ensuring all actions have been implemented, validated, and documented. Obtain approvals from both internal management and the customer. Many OEMs require a plant or quality manager to sign off. Archive the supporting data and update the portal status to closed or accepted. Then recognize the team, publicly acknowledge the cross-functional effort, share customer feedback, and celebrate the success. Recognition reinforces the behaviors you want to see again. Different customers use different portals, but patterns repeat. Ford's portals emphasize a clear evidence trail and feeding lessons learned into future projects. Ford used Covisint and FOSN portals to follow claims. GM's portal requires a rapid cadence of updates and emphasizes data and next steps. GM used Supply Power/PRR portal. Stellantis demands logic chains and proof of standardization and use SQP portal. Volkswagen, Audi use KPM-QS, and they looks for evidence of standardization. Mercedes wants detailed governance and use QEC tool. BMW and Toyota have their own forms. BMW use QMT portal and Toyota use SQAM portal. Tesla use SCAR portal as well. Regardless of portal, suppliers should follow the 1-5-20 rule. Within 1 day, define and communicate containment actions. Within 5 days, submit root cause analysis and corrective actions. Within 20 days, prove the fix and communicate actions to prevent recurrence. All portals want concise notes, time-stamped updates, and attachments like gauge studies, cause tests, corrective action verification data, and capability charts. They reward clarity and penalize vagueness. Understanding each customer's focus lets you tailor your reports and build confidence. Let's ground all of this in a realistic case. Suppose the target hole diameter is 10.00 millimeters plus or minus 0.05. The customer reports 8% of parts arriving between 9.86 and 9.89 millimeters. Their line stops. You trigger D0, stop shipping, segregate suspect parts, implement 100% inspection, and declare a clean point at 14:25 on September 5th. Lot B271. You record quantities, inspection methods, and attach the log. In D1, you assemble your cross-functional team with process, quality, maintenance, tooling, logistics, and a sponsor. You set a daily update time with the customer. During D2, you write a measurable statement and build your IS/ISNOT grid. The problem occurs on line B, operation 20, heat lots H12 and H13, mostly on shift B near the end of tool life. It does not occur on line A, shift A, early tool life, or heat lots H10 and H11. You verify the gauge, bias acceptable, linearity marginal at the lower spec, and collect data on coolant concentration, tool cycles, and hardness. You set a target CPK of 1.33 or higher. In D3, you install a temporary pin gauge station with tightened sampling at the end of the operation and mark separate dirty and clean zones. You run a false negative challenge and record 0 escapes during containment. For D4, you generate hypotheses: coolant drift, tool wear, fixture mislocation, gauge bias, material hardness. You run titration tests and plot coolant concentration versus defect rate. Shift B shows a drop to 4.8% just before the defect appears. You analyze tool life and see the diameter trending down near end of life. Fixture repeatability is clean, hardness normal. Gauge linearity is marginal, but not the root cause. You intentionally run the tool past its life and lower coolant concentration. The hole goes undersized. Raising coolant and resetting tool size eliminates it. You conclude the occurrence causes are combined coolant drift and tool wear. The escape cause is an insensitive gauge and sampling gap. The systemic cause is missing control in the design and maintenance system. In D5, you select permanent actions. Install an automatic coolant mixer with low-level interlock and daily titration checklist. Add a tool life counter with and-on and interlock. Replace the gauge with a more sensitive digital indicator and revise sampling frequency. And update the PFMEA and control plan. You verify cost and side effects and train operators and maintenance on the new systems. In D6, you validate. A provocation test shows the interlock stops the machine when coolant is low or tool life is exceeded. SPC charts show stability after the fixes. Capability improves to CPK, greater than or equal to 1.33. Product audits confirm holes stay within tolerance. You remove containment with customer approval. In D7, you update drawings, PFMEA, control plan and maintenance plans. Implement the same controls on line A and the sister plant. Add LPA questions, and capture lessons learned. In D8, the customer accepts the report. You archive the data, issue a one-page lesson card, and thank the team. Implementing these controls not only solved the problem but improved process capability across similar parts, reducing PPM by more than 30% and slashing complaint calls. What happens when you execute a world-class 8D? You transform a crisis into an opportunity. Investing in prevention, measurement, and error-proofing reduces the cost of poor quality dramatically. In our case, the new controls cut escapes by over 30%, halved complaint calls, and paid for themselves through warranty savings. Team members learned new problem-solving skills, the company's reputation improved, and future products will benefit from the lessons learned. That's the real payoff. You don't just fix one defect, you build organizational muscle that makes tomorrow's problems easier to solve. Today we talked about how to use the 8D problem-solving approach to eliminate recurring failures and improve quality. We reviewed the core steps, key checklists, and the tools you'll need to drive continuous improvement. In our next training video, we'll take a closer look at each stage from D0 through D4. We'll show you step-by-step how to respond to emergencies, assemble your team, define the problem, and conduct root cause and escape analyses. By following this series, you'll be able to perform much more effective analysis in your own work and implement solutions that stick. If you'd like to see more content like this, please don't forget to like the video and subscribe to the channel. And if you have other topics or questions you'd like us to cover, please share them in the comments. See you in the next video.